Okay, our aim once again is how do we approach triangle similarity proofs? To very quickly review, what are the three different ways we can prove two triangles similar? Well, I can use the angle-angle similarity postulate. I can use the side-angle-side similarity theorem, or I can use the SSS, the side-side-side similarity theorem. So let's take a look at a third example. Again, if you want to know what these actually mean, you need to go to your textbook or listen to the first two videos, and it's explained in more detail. Let's take a look at the question that we did in class. So it says, given point A bisects JK, C bisects KL, B bisects JL, prove that triangle JKL, the large triangle, is similar to triangle CBA. Okay, so let's try to remember a theorem that we learned earlier in the year, and that has to do with the midsegment of a triangle. And first of all, what is the midsegment? Okay, midsegment is a line segment that joins the midpoints of two sides of a triangle. So for example, line segment AC is the midsegment of triangle JKL. And what properties does a midsegment have? A midsegment, we've learned, is number one, parallel to the third side. And a midsegment is also half the length of the third side. So in other words, because AC is a midsegment, AC is parallel to JL, and AC is also 1/2 the length of JL. Those are the properties of a midsegment. So the definition of a midsegment is a line segment that joins the midpoints of two sides of a triangle. The properties of a midsegment are that a midsegment is parallel to the third side and is half the length of the third side. So how is this going to be used to our advantage? Well, if I know that AC is half of JL, and I know that BC is half of JK, and I know that AB is half of LK, then I know that there's a ratio of 1 to 2 between the small triangle and the large. Let's take an example. Suppose I say that BC is 3. That would mean that JK must be 6. And suppose I know that AC is 4. That would mean that JL must be 8. And suppose I know that AB is 5. Well, that would mean that KL must be 10. And I know that 4 is to 8 as 5 is to 10 as 3 is to 6. In other words, the ratio of the small triangle to the large triangle is 1/2 in each case, which means that all the sides are proportional to the 3 corresponding sides of the other triangle. But we want to use a two-column proof to show that, not use actual numbers, because they're not giving us numbers to use. They're just giving us the fact that A, B, and C are A, B, and C bisect the line segments. So here are my statements. Here are my reasons. Let's get started. So statement number 1 is going to be that A bisects JK. Let's get this in order, actually. B bisects line segment JL, and C bisects KL. Okay, and the reason for that, obviously, is given. So these points are line bisectors. Well, what does that mean? That means that A is I'm going to use shorthand, midpoint of, let me actually write this out and then I'll use shorthand afterwards. A is the midpoint of JK, and B is I'm going to use shorthand, midpoint of line segment JL, and C is the midpoint of line segment KL. Why? Well, what is the definition of a midpoint? It's a point that bisects a line segment. So I can just say definition of midpoint. Okay, so now let's see what we're going to do. Each of these line segments that joins the midpoint is called a midsegment. So I don't need to say that AC is a midsegment, but I do need to say that line segment AC is 1/2 of line segment JL. And I do need to say that BC, line segment BC is 1/2 of line segment JK. And the next thing I'm going to say is that line segment AB is 1/2 of line segment KL. Why is that? Well, that is the property of the mid segment of a triangle. A midsegment is half the length of the third side of the triangle. So here's what we're going to do. We're going to do some division. What I want to show is that the ratio of the three corresponding sides of the small triangle is proportional to the three corresponding sides of the other triangle. So here's what we're going to do. In each case, let's take the case of the first one. Let's take this right over here. I'm just going to rewrite this. This is my scratch pad area. AC is equal to 1/2 of JL. If I were to divide both sides of my triangle by JL, what would I have? Well, first of all, the JLs on the right side would disappear. And that would mean that AC is to JL. Let's try to write this without the line segment so it's easier to see. AC is to JL, that's a C. AC is to JL as 1 is to 2. AC over JL is equal to 1/2. And I can do that with each one of these. I can do that with AC and JL. I can do that with this statement. I can do that with this statement as well. So in other words, what I can do is I can just rewrite each of these in the statement number 4 by saying AC over JL is equal to 1/2, comma. I can also say BC over JK is equal to 1/2. Remember, what I'd be doing is essentially I would be dividing both sides of my equation by JK. So BC over JK, which is right over here, is the same thing as 1 over 2. What's left? Over there. Let's get rid of that so I can get back to where we were. Beautiful. And I can also say that AB over KL is equal to 1/2. What's the reason for that? It's called the division property. Division property of equality, which says I can divide both sides of an equation by the same amount and not change anything. If I'm dividing both sides of my first equation by JL, I haven't changed anything because JL is JL on both sides of my equation. Well, let's see what I've got here. If all these are equal to 1/2, if all these ratios are equal to 1/2, then it means they all must be equal to each other. So my fifth statement is going to be, well, AC is to JL as BC is to JK as AB is to KL. If you want, you can call this substitution. You can also call it the transitive property. Either one. You can say I'm substituting BC over JK for 1/2 in this statement, in this expression, in this equation. Okay. So now let's see what I got. AC is to JK. AC is to JL as BC is to JK, as BC is to JK, as AB is to KC, as AB is to KL, as AB is to KL. Well, what does that mean? Three sides of one triangle are proportional to three corresponding sides of the other. Therefore, I've got the thing I was asked to prove, namely triangle JKL is similar to triangle CBA. You guessed it, by the side similarity theorem. And there you have it. Make sure you take this down in your notes. You're responsible for all of it. If you need to, put your player on pause or review it, but make sure you've got it.